Hello. Let us see how multiple 7-segment displays like 1, 2, 3 are handled from the microcontroller output. For the purpose of simulation, we have taken logic 1 conditions here and logic 0 conditions here. As we know that logic 0 means this transistor will not conduct, nor this, nor this. Logic 1 means this is high and all such points are high. As you have seen in the 7-segment earlier, that if in this common anode 7-segment display, if this is given common positive and any of the limb is given negative, that particular limb will glow. Here we will see how a number of such 7 segments which are connected in parallel, all the segments are connected in parallel like this, and how we will get a reading of a particular number. Now let's power it and see how it works. These are switching transistors, and we know if these switching transistors are not switched on, that particular segment, that particular display unit will not get positive supply. Now let's see that while powering it. Now supposing I make this as 0, this as 0, and this as 0. And we know that unless I give power, this number is not going to be displayed. Or I give a 1 condition here, that is logic high, which will switch on the corresponding transistor. Now if I give this, this gives 7. Or if I switch off this, I give this, this gives 7. So exactly what we do is, now for example, when the digit 7 data is coming from the microcontroller in this fashion, 0, 0, 0 and 1, 1, 1, 1, in that particular event, this is given high. Now supposing the next digit that has to come from the microcontroller is, say, 1 and 1, 0, 0 means you will get 1 and 1. That time this will be switched on. That means this will go logic high. 0, 1, 0. Now supposing all are made 0 here, we know that this will become 8. Or for the purpose that if this is given high, this becomes 8. That is how we first got 7 here, 1 here and 8 here. That means when the data for 8 is coming, this is made high. When data for 1 is coming, like for example, when the data for 1 is coming, this is made high. Sorry. These two are made low. When data for 7 is required, these 3 are made low. And that is how this, when the data for 7, 1, 8 is coming, it is coming in this fashion from the data pins, and at that time the corresponding transistor is switched on. And all these happen at such a high rate, that means 1, 0, 0 or 0, 1, 0 or 0, 0, 1, they happen in such a fast rate, we call it multiplexing. They happen in such a fast rate that all the digits will appear to be stationary. In fact, each digit is visible only for once, while the data which is coming from the controller is in serial condition. That means when 7 is coming, this is switched on. When 1 is coming, this is switched on. When 8 is coming, this is switched on. And that is how it is giving such kind of reading because of our persistence of vision. Our persistence of vision is that for 1/10 of a second, we can 1/10 or 1/16 of a second that we can see, even if this is off. And when this changes from here to here and here to here, because of persistence of vision, we still see this digit. That is why we see in a continuous manner 7, 1, 8. And that is what is the process of number of 7-segment displays connected in parallel work together.